242. Our victim is ready to reach out to us and give us a shell on port 4242. Then we hit enter. Make sure that the server is running. And once the server is running, we can come back here. Let's re-execute. So if we run this time, instead of just writing test.txt, we should get a reverse shell here. So let's send the request again. It looks like it worked. And back here, we actually connected. We actually connected back to a vCenter server that we had no idea what the credentials were. And we can say, who am I? The worst thing that can happen is you say, who am I? And you are root. Hello, my name is Howard, and today I'm going to talk about the Log4j vulnerability and also show you a practical example of how attackers are exploiting this vulnerability. I'll be using VMware vCenter as an example on showing you how easy attackers are actually using this vulnerability as a way to emphasize the importance of you to be able to fix it and also implement any changes that you need so that your employer or your company is not vulnerable. So the Log4j or Log4Shell vulnerability affects Log4j library, and it's an open source library that a lot of people, a lot of developers use in their software for logging purposes. So what happens is when you deploy an application, you want to make sure that you have enough logging so that you can troubleshoot what's going on and what the problems are. In this case, if you used the Log4j library and your application uses Java, then chances are you are very vulnerable and you need to fix that as soon as possible. Any version that is before 2.15 is vulnerable. There's this feature called JNDI or Java Naming Directory Interface. Java Naming Directory Interface reaches out to other endpoints for external data. For example, in this case, our VMware login page can be set up so that you can use internal LDAP servers, which meaning like Active Directory or any other LDAP servers for authentication. And to do that, we can actually reach out to an LDAP server to get a username and password, verify that they are who they are. Then this web form can be filled by this application. Because of that, in this case, an attacker can actually send a specific message can be logged on the application. So if your application is logging everything that users are doing from the endpoint perspective, an attacker can craft a specific message and forward it to the JNDI or that interface and trick it into reaching out to an external DNS server or LDAP server. And when that happens, usually that fails. And if it fails, it gets logged to say, hey, we reached out to this external server and that failed. Okay, so that's okay, except in this case, when you're using Log4j vulnerable versions, that log message is kept in the logs file. And when it's in the logs file, an attacker can send a specific message with a specific payload that will be sitting in a log file. And this JNDI capability also allows that system to execute that command or that message that was in the log file. So let me show you how this works with a practical example that is easy to follow. I have deployed VMware vCenter here in VMware Workstation, and I have two versions. I have 6.7 and I also have version 7. Both these versions are vulnerable, and these are both Linux appliances, and this works even in Windows appliances as well. So what do we do? First, according to this diagram here, we are going to need an LDAP server, which is a server that VMware is going to think that's where it should find if users can authenticate or not. So we need to set up our own LDAP server as an attacker. So I'll go to my Kali Linux. All right, so right here in my Kali Linux, I'm in the temp directory. I would like to set up an LDAP server that will be responding with malicious payloads to the victim. So every time we go to this login page here and we say, hey, let's try to sign in, we can trick this login page to reach out to our LDAP server. Well, the good thing is there's a well-known malicious word LDAP server on the internet, Rogue JNDI. And this one here works with Java-based applications. So if you want a malicious LDAP server, this is an example. There's a bunch of them right now on GitHub, But we can set up an LDAP server that can respond to things like DNS queries or, in this case, LDAP queries. So to set this one LDAP server here, you need to have Java 7 Plus and then you run the man package command. First, we clone the repository. This is how the magic is going to happen here. First, we clone that repository and say, okay, let's git clone it. Rogue JNDI. And as you can see, if I do an ls in here, we just have the source, POM, and everything. Attackers don't have to do anything here. We can weaponize this after it has been set up. So if you have all the requirements that they're talking about, in this case, it's just having Maven 3 and Java installed, which you can figure out how to install. You just need to run Maven package. And this is the command that will create our LDAP server or anything that we want in this case. So let's just run that command, Maven package. And this is going to build our server for us. So as you can see, it finished building the two. So now we have this target directory. If you go to that target directory, you will notice in this case we have two original rogue JNDI. We want to use this rogue JNDI.jar here. All we have to do is go back to the Git repository, and this is the usage. So this is the command that we have to run. It says we're going to run Java, and it's going to refer to the rogue JNDI file. The rogue JNDI file, all it's doing is giving us the capability to run commands on the remote system. So in this case, it's going to reference our rogue JNDI.jar. This is the file that does most of the work for us, and we can put any command that we want here in here. So let's put any command that we want. Let's say touch test.txt, a test.txt file, and I would like that to be in the /tmp directory. So this will create a test.txt file in the temp directory on our system. This is a Linux system, so I put the touch command in here. Okay, the host name is going to be our Kali Linux system that we want to make sure that it actually runs. So if we hit enter here, it will start an HTTP server and an LDAP server. So in this case, the LDAP server is what is going to be used by the victim to reach out to us. And remember, our victim is this VMware vCenter. Is going to reach out to our LDAP server thinking this is where it can use for authentication. So we now have an LDAP server. So looking at this diagram here, it said an attacker has to send a request to the victim, trick that victim to reach out to our LDAP server in this case. Then of course the LDAP server is going to pass any strings or any commands that we want in this case. So how are we going to trick the victim into reaching out to our LDAP server since it's already here up and running? This LDAP server, once it's reached out to, is going to try to send touch test.txt here. All right. So before I show you how to reach out to the VMware server, let's do one more step here. Let's run the SSH command and SSH into our vCenter so we can actually see things. So this is the victim. I want to be able to go there. Now I type the command shell. I'm in there. I want to go to the temp directory and I do an ls. As you can see, in the temp directory here, this is on the vCenter that we were trying to exploit. I don't have anything. My command here said, if I reach out to that vCenter and it works, I should have a file called test.txt. So far we haven't triggered this yet. Now we just need to make sure that we can trigger the vulnerability on the vCenter server. So going to vCenter here, first I actually have Burp Suite here, and I'm going to set interception to on. We have our vCenter server on. So we're just trying to go to vCenter's login page. Let's see, what does the request look like? I'm going to use a tool called Burp Suite to show you. I'm going to set interception to off for now. So here's a login page that we can have. Of course, I don't have any certificates, so you need to make sure that you send your request as insecure if you don't have that. So I'm going to launch that in HTML5. This is 6.5, the one that I'm attacking right now. Okay, so this login page here, as you can see, this is what we're going to be abusing. We're going to trick VMware vCenter to think that, hey, when someone signs in on this page using a username and password, send them to an external LDAP server, and this server is supposed to authenticate who they are. Then if that server says they are who they are and they're correct, forward them to what they have access to in vCenter. And as you saw earlier, when you fully sign into vCenter, you should be able to see a lot of things here that you can change, including all the machines if they're in there. So we're tricking it to say, hey, reach out to an LDAP server. And we have already created an LDAP server here. This is the server that we're going to tell it to reach out to. And within Burp Suite, I can show you what that request looks like. If we refresh this, this is what the request looks like. It will send a, in this case, we just sent a GET request to the main page, but what is going to be sent there is this single sign-on on the vSphere.local. And this is very important. Being able to identify that we're using vSphere.local. If you're using a different domain name, this will be different, and a lot of attackers won't be able to use it. But we're sending it to vSphere.local and on this host here. So once we know that that's what we are sending, we can make that command, instead of sending it via Burp Suite, I really like the curl command better. So here's a curl command that we can send. We can say, hey, curl, send it in an insecure, because we don't have certificates in this case. If you do that, then we want it to be verbose, like very verbose. So we're using 2 V's. We're going to send it in the header, which is exactly what you see in this case, which I was sending it via Burp. We want you to send it to an X forwarder, is what is used to reference other locations where things can be sent to. In this case, we want a JNDI. Remember, I explained what JNDI earlier is. So this is the Java naming directory interface. And it's going to say, hey, for LDAP references, send them to this IP address. Well, do you know who this IP address is? It's actually our Kali Linux machine right here. So it's going to send it to Kali Linux, and it's going to use the Tomcat, because that's how we can execute Java. And then we put the IP address of our vCenter. In this case, that's the same exact request that I just showed you. So when you send this, it's going to reach out to our LDAP server and say, hey, do you have users for me? And when it does that, our rogue LDAP server is going to say, oh, I don't have users, but I do have a command for you. So you do execute touch test.txt. And if that happens, we should be able to verify in this log file that that command ran, and that should work. So let's go ahead and actually execute it right now. So let's go ahead and run the curl command to our system. And as you can see here, it actually does hang for a little bit. And if you go back, oh, look at what happened. We actually did process some requests from that victim here. I do see these 4 requests here. This shows that it did work. So our command worked on the system. So let's go to our vCenter. Here is your log file. The websso.log, this is where you are going to see that. So I'm going to cat that file. Then I'll pipe it to grep JNDI. Let's just grep JNDI. And as you can see in the log file on our victim system here, it actually did execute reaching out to LDAP. What else should we be expecting? We should expect it to have run the command touch test.txt. So what should happen is, if I do an ls on the temp directory, I should see test.txt having been executed here. So let's take this further. Let's do another test. Make sure that it's actually working. First, we'll stop our LDAP server, and we just change this test to hacked.txt, right? We start the server, and it's running. Let's rerun the curl command again. It said it worked. Let's go back and rerun ls temp. We should see a file called hacked as well. And here it is, hacked text.txt. All right, so this is not exciting. We don't want to just be writing text files to the temp directory. Let's see if we can actually execute netcat commands or a reverse shell here. So first, to get a reverse shell, you probably get the idea by now. We come back here. Whatever we put in these brackets here is going to give us a reverse shell. So that's what we're going to be doing. Let's see what can we use for reverse shells. I'm going to use my cheat sheet to show you that having notes is really, really important as an attacker. So in my reverse shells, I just have a netcat command here. Let's just run netcat because most Linux systems have netcat installed anyway. So let's come here and say, hey, netcat, can you execute bash? And then this is going to say, hey, netcat, can you reach out to our attacker on 192.168.38.171 on port, say, 4242. And what we need to do now is on our attacker machine, we need to say netcat listen on port 4242. So netcat is listening on port 4242. Our victim is ready to reach out to us and give us a shell on port 4242. Then we hit enter. Make sure that the server is running. And once the server is running, we can come back here. Let's re-execute. So if we run this time, instead of just writing test.txt, we should get a reverse shell here. So let's send the request again. It looks like it worked. And back here, we actually connected. We actually connected back to a vCenter server that we had no idea what the credentials were. And we can say, who am I? The worst thing that can happen is you say, who am I? And you are root. That's bad for any company. And as you can see, we are root. So let's fix this shell so that it's actually better and we can interact with it. I'm going to use Python. Now we have a nice shell. So we can cd search home and see some users. So as root here, I can actually use this system for lateral movements, maybe to try to scan your Active Directory environments, to try to get to even more interesting systems. And I haven't looked at this, but I can even try to see if I can interact with your ESXi hosts that you have in there. So this is really, really dangerous. So if you have vCenter 6.7 or in this case 7.03, which is the tool that I have exploited, I highly encourage you to fix these vCenter servers, especially if they are exposed to the internet. So that brings us to how do you fix it? I found that VMware is working really hard to fix it, and they probably have a fix by now because I made this video soon as this came out. But there's a workaround. There's multiple ways you can use to fix, and this GitHub repo here really works. I applied this workaround on my server, and I tried to do my exploit again. It didn't work. So if you need to fix your VMware, make sure to come in here and follow around here. Or here's a KB article from VMware that you should be following. There's a VMware response here. Make sure to update your vCenter appliances. And if they are exposed to the internet, you want to disable that exposure right now, and so that they don't get exploited, because it's very easy. There is no barrier to entry here. Any script kiddie can actually access your vCenter. And this applies to anything else that's out there. So if you really, really have to, please make sure to update. There's a lot of things that you can do to make sure that you update. And if you go back to here, there's mitigation issues that you can find here. One of the things that was mentioned as part of mitigation was to make sure that you have changed this line here in your code, the log4j2 to true. That's one of the mitigation strategies. Remove the LDEP class if you're not using it. If you're not using LDEP, just make sure that you just remove that. And there's ways to detect it as well. So make sure that you add all the rules. I did find a few days ago on GitHub, there's a bunch of Yara rules that you can follow. There's a lot of Snort rules that you can update and a lot of Security Onion rules that you can update. So please make sure to update your VMware vCenter and also implement proper detection, because this is serious business. That was it. I just wanted to show you. If you like this content, please like and subscribe. I'll be making a lot more videos that are very interesting for both attackers and defenders. Otherwise, I will see you next time.